Hello students, let's read this question. A plane is traveling at a height of 8,500 feet and descends at a rate of 380 feet per minute. The following table shows some values of height age of the plane after t minutes. Okay, and the question, which equation best represents this situation? Okay, so they said the plane is traveling and the height is 8,500 feet. Then it descends, so it means it's going down. The rate is 380 feet per minute. Then the table represents this data, and they have the height, age, and the time in minutes. And the question is, which equation represents the situation? Okay, with it circle and underline the important information, we box the question, and our next step is elaborate. Remember on the last questions that we solved together, our first step was identifying the pattern on the x-axis and on the y-axis, left and right side of the table. So for x, we have, instead of x, we have a t, that's on the left side of the table. So we always have the same order, guys. The x comes first, so the x in this case will be the t. And on the right side, we have the values for y, and in this case will be the letter h. But it's exactly the same type of information that we're gonna work. And then here, I'm gonna be using the orange. So the values on the right side will be the orange. Great. What I'm gonna do next is I'm gonna have to find what is the difference between each two of my numbers. So let's do this one first, guys. 1,820 minus 6,600. Can you help me to subtract? 0 minus 0, that's 0. 2 minus 0, that is 2. 1 minus 6, we can. We're gonna regroup. 11 minus 6, that is a 5. And 7 minus 6, that's 1,520. Okay, this is the first difference. Do we have to find the other difference? Yes, we have to see how the pattern is working. Now from here will be 6,600 minus 4,700. And let's do the subtraction, guys. 0 minus 0, that's a 0. 0 minus 0, 0. 6 minus 7, we can. So we have to regroup. It's going to be a 5, and this is going to become a 16. 16 minus 7, that's going to be 9. And 5 minus 4, that's going to be 1. So the difference from this value to this value is 1,900. Now I'm going to check on the other side. From 1 to 5, the difference is 4, and it's positive 4. And from 5 to 10, the difference is plus 5. Now, at this point, guys, notice that the difference is not the same one. But what I really need to check is that the rate of change is the same one. And how do we check that? That was our second step, remember? Finding the value of m. That is also called the rate of change. And so we can find that rate of change. We already said that we need to find the change on the y-axis divided by the change on the x-axis. And in this case, the right side of the table is where we have the h, and that will be our right side of the table. And the left side of the table, you see that here, guys, where we have the x is the same as when we have this little t. Okay, so we're gonna do our operations, and because I got two different values, I'm gonna do this twice. If the rate of change is the same with the two different changes that we measured, then we can use that value as the rate of change that is describing the whole data or the whole table. And so that's what I'm gonna do right now. The other thing that I always can predict is the sign of my rate of change. Remember? And how do we check that? By checking how the values are either increasing or decreasing. If I go from top to bottom, from 1 to 5, the value is increasing, so that make it positive. And then from 5 to 10 keeps increasing, and the values keep increasing all the way down, right? So then that makes these changes positive. Now let's check on the right side, on the y side or the h side. From 8,000 to 102, from 8,120 to 6,600. What's happening to this value? Is it going up or is it going down? Yes, it's going down. So this value here is going to be negative. And when I go from 6,600 to 4,700, I went down 1,900 units. So then that makes this negative. Now, look, because we're going to divide the change on the y-axis, that is negative, divided by the changes on the x-axis that we got it positive. From here, we can predict our sign. What is the answer, guys, when we divide a negative by a positive? Yes, it is going to be negative. When we divide opposite signs, the answer is going to be negative. And now I'm going to do substitution. So I'm going to work with this value that goes with this value first. And remember that this sign right here means division, long division. So we're going to do this long division. And I'm going to do substitution. On the y side, I said I have 1,520. And then on the left side, on the x, I have a 4. And now I'm going to divide. 4 times what is close to 15? The answer is 3. Great. 4 times 3, that's a 12. We subtract 15 minus 12, that is a 3. This is okay. This number always must be smaller than this number here, than the 4 in this case. We bring down the 2. Now 4 into 32. Excellent. 8 times. 8 times 4, that is a 32. We subtract. We have one more digit to go. And that's a 0. 4 times what will give me 0? The answer is 0. So looks like our rate of change should be negative 380. But because I got different values on the next difference on the y side, I'm going to do the next one too. And so for the next one, I'm going to do long division. And now I'm going to do on the y-axis is 1,900. And then the x-axis is this 5. So now we're going to be working with these two. And that's going to be 1,900 divided by the 5, right? So 5 times what equals to 1. That doesn't work. We need to take one more digit. 5 times what is close to 15? The answer is a 3. 5 times 3 is 15. 19 minus 15, that is a 4. Bring down the 0. That's going to be 8. 8 times 5, that's a 40. 40 minus 40, that's going to be 0. Now bring down the 0. 5 times what? 0. Well, that's a 0. So you see how that 2 times we got the same value? Great. So definitely that means our slope is going to be negative 380. That's the value of the rate of change. Okay, great. And then we said the third step is always to use the general equation of the line, which is y equal mx plus b. And then in this case, the value of the slope is negative. So I'm going to put this in a red box because we got it negative. And then we need to figure this value here, the b. Remember, how do we find the b? We have to go to the table and find when the x is 0. But here my value, my smallest value is a 1. So I don't really have it. But what I can do is try to see what pattern is following. So I'm gonna erase the x and the y on the very top. Okay, so yes, we said we needed to find the value on the left side when that is 0. And I can see that the 0 will be on top of this one because you see 20, 15, 10, 5, 1. So the 0 is smaller, so it should be before the 1. Now, what's happening on the other side? Well, I went from a 900 to 2,800 to 4,700 to 6,600 to 8,120. So what do I know about this value? The only thing that I know is that it's going to be more than what value? it needs to be more than 8,120. Why? Because the values are increasing. If I go from bottom to top, and I need to get to the top because I need to get to the 0. So look, from 0 to 2,100, it's getting bigger. 4,007, bigger, bigger, bigger. So what I know is that if I go more towards the top, this number needs to be bigger than the one before this number. And then also I know this one, the 0 needs to be on the top, because look what's happening on this other side. From 20 to 15 to 10 to 5 to 1. So the 0 for sure will be on top of this number. If not, that I get a number even smaller than this. So that's all what I know right now. And with that information, I'm going to analyze the choices. Okay, so for the y, it stays the same. The value of the slope is negative 380. And it has an x that is multiplying. And then plus the b. But the only thing that we know about the b is that it needs to be more than 8,120. That's all what I know. Now the only thing, the other thing that's happening here, they don't use a y. They using what letter here? An h, but it's the same. And then this number stays the same because it's the same table. And instead of x, they're using a t, so that should multiply the t. And then at the end, we should be adding the number that is more than 8,120. There. And so with this information right here, I'm going to analyze my choices. Let's analyze choice A. So the first value that we got is an 8,500 and plus 380 that multiplies. That's multiplying the t. And then here we have, this is the independent number, you see? Because it has no variable next to it. Okay, so the number that is going to be by itself with no variable, it needs to be more than 8,120, and this number is greater than 1,820. So this might work. But what's the problem here, guys? We know the slope is negative 380, and this has a positive in front. So that means this cannot be the answer, and it is multiplying another value. So this section here, it will be like this, but it got an opposite sign than what we need. So this one cannot be your answer. Great, let's check the next one. This is the value that is multiplying a variable, like what we have here, but we know that this one needs to be the number next to the variable. So that means the rate of change multiplying the t needs to be positive, negative. And this one is positive, so we cannot take this one. And then what about the 8,500? We also know that the number that is by itself, like this one, that has no variable, the 8,100, that needs to be more than 8,120. But we got negative 8,500. This is opposite sign, so then this cannot be your answer. And now we're going to analyze the choice C. Okay, so the independent value, the one that has no variable, is 8,500, and we are expecting a number more than 8,120. So this is right. Now the other value, and you see how in the equation that I have, I always write my 380 with the variable, the rate of change with the variable, at the beginning of the equation, and then the independent number at the end. But it doesn't matter, it can be switching here and it still is the same answer. Okay, well, what is important here is to identify the value that is next to the variable, because then it will be this one here. See? And we know it must be negative, so okay, the value needs to be 380, and it needs to multiply the t, and it is doing it. So seems like everything is working here. So I'm going to put a question mark on that one. And now we're going to check the last one. The 380, we know that it needs to multiply the t. And in this case, it's not multiplying anything. So this is not going to work. Then this is a number more than 8,120. But look, that number needs to be by itself. That cannot have any variable next to it. So then this is not a possible answer anymore. So then because of this, our only possible answer is choice C. Great, we found our answer. This is a good one. Now, we did this method trying to find the equation when we have a table. But another way is by doing substitution. So what we do in that case is we check each of the choices. And every time that we see an age, we do substitute one value from the table. Like these two values that are in the same row, we plug them in. And when we have a t, instead we plug in the 1. We multiply, we add, and we see if we get this value. And if that works, then we check the next row and so forth. And the equation that gets all the values of the table, then that means that is our answer. We're gonna do one example. So I'm gonna do choice A. I'm gonna make some squiggles here, guys, to show that that's method 2. I wrote method 2 substitution in here, and that's exactly what I'm gonna do. I recorded choice A just so you can see how you can test each of the choices. So for choice A, this is the age, and the other values that we have are the t's that we have on the left side of the table. You see? Okay, so I look on every row. That's what I have to do. And I always start with the lowest numbers. Those are more friendly to work out. So I'm gonna plug in, do substitution of the first value of age, which is 8,120 equals, bring down the 8,500 plus 380 times the 1. And guys, look, this is 8,120. And on the right side, we're gonna add 8,500. This number just by itself is bigger than this number. So this expression is definitely not equal. It's not the same. And also they're gonna add another 380 times 1, which is 380. So this is gonna be really 8,830. And it's definitely, like we said, not the same as 8,120. We cannot pick that one. And when one of the values is from the table doesn't work, there's no reason why to keep checking the rest of the table if the first value is telling you already that the table is not working. The other way is, okay, the first set of values is working. In that case, we have to check all the values in the table. And that one, it takes more time. So that's the catch of doing this method. Okay, so now I'm not gonna do B because I know it's not working and I don't have that much space, but we're gonna do C so we can see why it is working. The equation on choice C reads age equals 8,500 minus 380 that multiplies the T. Okay, and we said the age is the orange side of the table and the T is the blue side of the table. And I'm gonna bring the first set of values. The first set of value for age is 8,120 equals 8,500. That's gonna subtract 380 times 1. This is the first value of the table, and the 8,120 is the first value in the table too. We're gonna subtract on the side 8,500 minus, and 380 times 1, that is 380. Remember, we line up the numbers by place value, and empty spaces I can fill them in with zeros so I won't misalign the numbers. 0 minus 0, that's a 0. 0 minus 8, I can't, so I have to regroup. This 5 will become a 4. The one we took away from there gets here, and then this becomes a 10. So now I'm gonna do 10 minus 8, and that is a 2. 4 minus 3, and that is a 1. And a minus 0, and that is an 8. Here we also got 8,120, which is exactly like the value on the left side. You see that, guys? So this equation, it is working. Method 2 by substitution, we didn't complete it because we completed the first way to do it, but just so we can remember that this is another option that we can have. And guys, thank you so much.